Good morning, happy mathematicians. It is March 19th, and we're ready for our next lesson. Yesterday, I sent you a three equation system, and I asked you to solve it using your old algebra techniques, brute force, and one of the equations looked like this. My guess is that the very first thing that you did was divide everything through by 5, so that you ended up with this. And then we used that to do probably elimination until we got down to a solution. But my question today isn't that old stuff. My question today is, if I only had this one equation, how many solutions are there to it? So back in Algebra 1, we might have dealt with something like that. And we would have said, oh, there are infinite solutions to that. And if I listed them all out and I plotted them all down, I probably would have gotten a straight line. Woo! Okay? But now today I've got a third variable. And so how would I deal with that? First off, how many solutions are there to it? Well, I could have, for example, 7, 0, 0. Or I could have 8, 1, 0, or 8, 0, 1, or 9, 1, 1, or 9, 0, 2, I could have infinite solutions. And the question is, what would they look like? So the first problem is that I no longer just have 2 variables, so I'm not going to be able to use a coordinate plane. I have 3 variables, and so I need a new axis. So let's start by thinking about what it used to look like. Okay, so I've got this here. Here's my x-coordinate, here's my x-axis, here's my y-axis. And now I need suddenly a third axis. So I'm going to now think about it like this. Here's x coming to you. Here's y shooting off to the side. And this guy here is my z-axis. Okay, so when I go to plot a point, let's say I'm plotting 9, 1, 1. I'd go 9 units on my x-axis. I'd go 1 unit over on my y-axis. And I'd go 1 unit up on my z-axis. And I would have a point right there in space. Okay, so the first thing I am going to ask you to do is to make yourself a model. This model here, it's just a corner of a box. And the only thing that I can really do in this model is plot points that are in that first octant where everything is positive. All of your x's are positive, all of your y's are positive, and all of your z's are positive. But the thing is, that's not always the case. And so maybe you want a different kind of model. So this guy here, I just made this out of hot glue and cake pop sticks, lollipop sticks. And so then I can define, hey, maybe this is my x coordinate, and maybe this is my y coordinate, and maybe this is my z coordinate, and then I can think about points in space anywhere within that model. Maybe I don't have cake pop sticks because, who does? Well, I know your parents went out and bought a lot of pasta because apocalypse, we're prepared. So this is just made out of fettuccine. I chose to use the fettuccine instead of the angel hair because it's a little bit more sturdy. Okay, so again, I can designate an x-coordinate, an x-axis, a y-axis, and a z-axis, and then I can think about my points in space. Let's say you don't have any hot glue. Let's say the only thing you have is paper. Okay, ba-bam, look at this guy here. This is just a really nice little model out of index cards. With this one, the thing I like about it is that then you can write directly on it like, hey, see that octant there? I can designate that that's my plus octant. And down here would be my minus. And so you can write directly on the paper to give you some guidance. Okay, so the point, my first challenge to you is go back to this equation here. I want you to write down a dozen coordinates. Not coordinates anymore, points in space, trios of values for x, y, and z that make this true. Write down at least a dozen. And I'm going to suggest to you that you try to, just in the beginning, try to find values that are positive for x, y, and z. Find at least 12 trios of values that make this true. And then grab yourself an imaginary set of axes, and just with your mind and your hands, imagine what things would look like. So like maybe I'm thinking I've got a point here and I've got a point here and I've got a point here, and what's that gonna look like? Oh my gosh. All right, so you're gonna do some 3D thinking. This equation, at least 12 trios of points. Try to keep them all positive in the beginning. Imagine where they're going to be and what collectively do you think they're going to look like. In just a little while today, I'm going to send you an updated video, or a video that furthers the question, so don't dally on this one. It's kind of fun. Have some fun. Little math craft. It's all good. Peace out.